this video, we're going to talk about the double angle identities. We're going to start off with looking at the double angle of sine. These identities are going to be used if we are given a triangle within the coordinate plane and we're finding the missing sides, or maybe we're trying to find specific angle measurements where we're given a theta, but we know that the other angle is 2 theta. Again, there's a lot of different reasons we might be using this, but this is going to be just the examples of how to use it, how to apply it, and why it is useful. So again, we're just going to look at sine, the double angle of sine here, and be sure to check out the other videos for cosine and tangent. So find the double angle of sine when the cosine of theta equals 1/3 and theta is between 0 and pi over 2. So if we're thinking of our coordinate plane, our measurement of theta is between 0 and pi over 2, which means that theta is going to be somewhere within quadrant 1. Well, when they tell us that cosine is 1/3, we know that cosine is the adjacent side over the hypotenuse. So we have our adjacent side being equal to 1 and our hypotenuse equal to 3. Therefore, when we use the Pythagorean theorem, we have 1 squared plus b squared equals 3 squared. So we have 1 plus b squared equals 9, and we get that b squared equals 8, which gives us that b is the square root of 8. And we can leave that as square root of 8. That's not a big deal. That gives us our missing side here. And now that we have all 3 sides, what I can do is I can use that third side to help me find the double angle of sine. So simply, I'm going to take my double angle of sine formula, and I'm just going to plug in everything that I have. So the double angle of sine equals 2 times, well, the sine of theta is going to be the opposite side over hypotenuse, times cosine, which we know is 1/3. Go ahead and simplify that out, and we have 2 times root 8 over 9. And that's it. Very simple, very straightforward, just plugging into a formula and going to town. So let's check out another one. This one's, again, fairly simple. Given that cosine of theta is -4 over 5 and 90 degrees is less than or equal to theta, which is less than or equal to 180 degrees, find the double angle of sine. Well, again, let's give ourselves a little bit more room here. I'm going to draw my triangle in here. I'm in quadrant 2 because we're between 90 degrees and 180 degrees. So our triangle is going to look something like this. And they tell us that cosine is -4 over 5. Now, if you are familiar with Pythagorean triples, we know instantly that this is going to be a 3, 4, 5 triangle. If you don't, use Pythagorean theorem to solve for that missing side. And again, that's how we would get our third side. So, easy way to find our double angle: 2 times the sine of theta times cosine of theta. Well, we're just plugging in everything that we have. We have 2. The sine of theta is going to be 3 over 5. Cosine of theta is going to be -4 over 5, which gives me 2 times 3 being 6. 6 times -4 is -24 over 25. And that's it. Again, double angle of sine, very easy, very straightforward. I hope this video makes sense. Be sure to check out the video of the double angle of cosine and the double angle of tangent as we continue looking at these double angle identities. Thanks for checking out the video. We'll see you next time.